If you pull a guitar string tight and pluck it, you can hear the energy. That bright, ringing sound is a direct result of tension. The tighter the string, the more energy it stores, and the faster it vibrates. But if you take a pair of scissors and snip that string right in the middle, the vibration stops instantly, the tension disappears, and the stored energy drops to zero. Now imagine if the fundamental threads making up our universe were different. What if they were governed by a law that mathematically forbade them from ever breaking? Understanding this permanent, unbreakable tension is the first step to seeing how the universe builds substance out of thin air. Let's bend our string into a circle. If we join the ends, an energy wave can travel around and around that loop without ever stopping. But we can add a twist. If we snip the loop, flip one end over, and glue it back together, we create a Möbius strip. Now, our wave travels along a surface that turns upside down every single lap. Because of that twist, the entire shape pinches down to a single microscopic point in the center. Mathematicians call this bottleneck the cone point. That geometric pinch creates a problem. When a wave of energy tries to pass through that center, our standard understanding of physics hits a wall. As a pulse rushes toward that twisted center, the path effectively disappears. The wave has no room left to move. Standard math suggests an easy way out. Let the wave stop at the twist. In this model, the wave simply disconnects and its energy vanishes. This is just like the snipped guitar string. The connection is severed, the tension is released, and the system goes silent. On paper, baseline physics equations are perfectly fine with this. They don't mind if the energy simply disappears when it hits the twist. If the universe only followed those baseline rules, every wave crossing a geometric twist simply fade away, leaving space cold and empty. But reality doesn't allow for tears or gaps. There is an overriding rule that the fabric of space must remain a single, unbroken piece. To follow this rule, the math requires the two ends of the wave to fuse. It forces a continuous bridge across that pinch point, ensuring it never breaks. Forced to stay connected, the wave stretches tight across the center, creating massive internal tension. It's like turning the tuning peg on a guitar. By refusing to let the thread break, the universe creates a baseline level of stress that never goes away. The universe's demand for an unbroken surface means that the snapped zero-energy state can never actually exist. Because the thread is perpetually stretched, it can never stop humming. That forced connection creates a permanent vibration. This vibration has a specific, irreducible floor. No matter what happens, the energy can never drop below a value of 2 divided by the radius squared. This number is a constant. You can't cool it down or turn it off. As long as the twist exists, the energy persists. The geometry of the twist has trapped the energy in a state of permanent elevation. It creates an unbreakable floor that supports the rest of physics. When we zoom out from these microscopic mathematical loops and look at the universe on a larger scale, we see what this trapped energy does. In physics, energy and mass are two sides of the same coin. Think of mass as energy that has nowhere else to go. When you try to push an object, you are actually pushing against all that trapped, vibrating tension inside its atoms. That inescapable hum, the vibration forced into existence by the rule of connection, is what gives the universe its weight. It is what makes things feel solid. Everything you touch is a byproduct of these microscopic twists. Reality exists because these tiny strings refuse to let go. The weight of the world is the signature of a universe that simply refuses to break.